Today we're going to be looking at inspection and quality control. So it's one of the kind of areas of the industry where we have so many customers and clients. So obviously all the camera guys, AVTs, BSTs, Ultramats, all these kind of guys. But also in terms of the people who supply the links between those systems, so like ESCO, CERM, all the management information people who link all those cameras together with the factory management systems, and also the inspection rewinders. So quality control is really the process of making sure that the label that comes off goes actually out to the customer, to Coke or whatever, is exactly the same specification as the label that's agreed with the customer. Okay, so if I'm Coca-Cola or if I'm whatever brand, I get my proof, and when I'm at my desk, or I might get this on an iPad now, and I basically say, right, well that's what I want, and that's the label that's got to come off the end of the press. So once I've approved that, then the job of the label printer obviously is to make sure that every single label that comes off the back end of the press and goes into the dispatch area and onto the packaging lines is exactly that colour with those images. So that's really what quality control is about. It's about ensuring that the customer proof is the same as what comes off the end of the press. And if you think about what we're talking about here, you know, an average run length for Coca-Cola for a wraparound label might be something like 5.5 million labels. You know, it's a big run of labels, and every single label has the exact Coke red. If it doesn't have that exact Coke red, and somebody inspects that at a Coca-Cola packaging plant, the whole lot just gets sent back. The whole lot, just the pallet just goes back. So it's really critical importance that the colour's right, but it's not just a question of the colour. Obviously, the image has to be right. I mean, it has to be the right image. And mistakes have happened. The wrong sets of plates have been put on the press, and the wrong image has been printed and sent to the customer, and it's been just missed by everybody because no one's looking for it. Something so obvious. So the second place where inspection takes place, first of all on the press. So we have the camera on the press, and go to Label Expo or go and see a label printer. You always see at the end of the press the screen, okay, and you'll see the press operator looking at the screen and going back, making adjustments to the press, going back looking at the screen again. Then also on the rewinder. So after the label roll is printed on the press, it then goes onto the separate machine, which is the rewinder. Okay, and again, that's where we have a lot of customers. Okay, so when labeling has its roundup, just on the digital finishing side, we're already talking about, I don't know, 45, 50 companies, you know, and probably more. Okay, but it's the Pratties, it's the Smags, it's all the finishing guys. And that is that's the last point where you're going to do your checking. So after that, the label's going to be put in a box and goes to the customer. So the rewinder operator is often the most sort of lowly person in the plant, usually the worst paid people, the kind of people who they claim don't need any training. All they have to do is just basically look and make sure, but in fact they do, they're the key people, because if anything gets past them, it's a defect, it's going to go out. And that defect might be any one of a number of things. So it might be if you've got variable data that you've missed out a part of variable data. Okay, so maybe a 7, actually there's like a 9, or you know, you've actually missed out a digit. It could be that you've missed out some text hasn't printed. There are a whole range of things that person on that rewinder has to look for, and most of them are women, most of them are badly paid, and it's treated as being the kind of job that anyone can do, but in fact it's one of the most critical jobs in the plant. What we are seeing, and what you'll see at the automation arena at Label Expo, is this whole process, like everything else that we've been talking about, is gradually being automated. So what we'll see is that artificial intelligence. This is going to be one of the big areas where AI is going to really score, because what AI is going to do, if you talk to people like AVT or BST or Brotec is really pushing us hard. They now have all their cameras around the world linked into their servers, big data servers. So what these guys are doing, the cameras are looking at a job and saying, this went wrong in this job. We talked about this briefly, if you remember, in the automation session last time. But it's in the inspection side, because all that a person's doing is looking and make sure everything's correct, okay? So actually, the camera's looking at it. If the camera knows what it's looking for and the AI is telling it what to look for, then the camera can actually do a lot of that stuff. So in the next 4 or 5 years, probably the rewind operator, this person, you see them on the rewinder looking like this as the web goes by. So that's probably going to be one of the first jobs that kind of goes in this area. But that's kind of moving forward a little bit. But let's start from the beginning. So the earliest type of inspection system, and you still see a lot of these around, Unilux is a classic example, is a strobe. Okay, now strobe light, anybody sort of been like, when I was a kid, you go to discos and Michael Jackson song comes on and the strobe lights come on and you're doing this and the strobe lights come on and you just kind of, Okay, so that's a strobe light at discos and clubs. And so what it's doing is it's basically, it's breaking down a continuous movement, okay, me doing my silly dancing, breaking that down into discrete steps, okay? So effectively it's sampling a continuously moving image and just showing me it in sort of freeze frames, effectively. So that's what a strobe light does on a label press, because obviously that web's moving anything up to 150 meters a minute. There's no way that anybody can check what's going through, okay? So the strobe light shines on it, exactly like in the Michael Jackson thingy going on, and it's so what the operator sees is they actually see looks like just an image standing still, but actually what it is, it's sampling that image as it comes through. So that means the operator can now just look at that, and what they can see is if anything's starting to go wrong. Okay, so let's say that what they're seeing is the web running 120 meters a minute, say they'll be seeing every 2 meters. Right? So every 2 meters they see an image. Okay, so then they start to see that something's going wrong, the colour's going wrong, or digits been missed out, something's happening. Okay, so that's the old kind of manual inspection. You still see a lot of that going on, especially on the rewinders. The rewinder might be going anything up to 300 meters a minute, so these strobe lights are pretty fast. If you've got epilepsy, it's not a good job to have. Not a good job to have. And particularly again in sort of developing countries, you'll see a lot of this. Like in India, a lot of plants in China. A lot of presses are still fitted with these very old kind of Unilux strobe systems. Okay, inline video cameras we talked about. Optical character recognition. I'm going to come back to that in a second. But OCR is basically the same system that on the M25 the cameras use to read your number plate. Okay, so basically what these are doing it's actually reading and decoding numbers on a label. And then registration mark sensors, so we'll talk about that. And again, you'll see this when you see a Press Label Expo, have a look at the camera. And what you often see sort of 4 or 5 targets like this are coming together into a circle, and then when it hits the circle it goes green. So what that's doing is it's measuring. You have a web of labels and you can't quite see it. I don't think I've got any here, but on the margin of the label here, they'll print registration marks, which are normally just kind of crosses like that. So what the camera's doing is it's every time that one of those passes, it's just measuring it. So providing that measurement always stays the same, then the cyan will always land in the right place on the magenta, it always lands in the right place in the yellow will right place on the black. So what that's doing is it's just basically making sure that all the plates are aligned and everything is lined up. And I'll also talk briefly about a very new sensor that you'll see at Label Expo on the Bob's press, which is the UV sensor. We'll talk about that briefly later. Okay, so the strobe light we talked about the video camera. So the video camera, and again, this is where all of our kind of main guys, AVT is obviously the leader, BST, Ultramat, PC Industries. There's a whole bunch of companies out there who do video, and it's just basically a high resolution video camera. It just sits over the web. It's normally on a moving platform because the aperture can only cover about 2 or 3 inches, so it can't look at the whole web unless you've got special 100% web inspection systems which do cover the whole web. But generally speaking, you'll see them on a little sort of motorized chassis like that, moving across the web, scanning across. So the video camera, the way that they basically work is they take so when you make ready to press, okay, so you've got your plates on, you just start out to press slowly, making sure that everything's lined up and nothing's kind of falling off, all the image is correct. And just before you then start, you then ramp the press up to full speed. Just before that point, the camera takes a photograph, bang, of the web. And that becomes, it's kind of what they call a golden image. So what it then does is it then uses that as a reference point for its inspection. Okay, then so as the web starts to ramp up to full speed, it uses that first image to check every other image that goes past. And that's fine, unless there's something wrong with the first image, the first printed label. So what it's not very good at doing is fine if everything is under control and you definitely know it's the right label that you're printing and everything's right on that label, all the characters are there, all the brand colors are fine, and then that's a great system. If there's anything wrong with that initial label, then obviously everything's going to be wrong. So that's that's one issue which automation is going to tackle, as we'll see later. Okay, the other problem with the golden image system is it's not very good at checking for variable data. So let's say that you have like a farmer label, and every label now has to have a unique serial number on the label. Well, because it's only taking like one photograph of the first lot of images, it's not very good at detecting. So the next label is going to be 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 7, 1, 2, 8. It can't check that stuff, so it can't check variable information. That's where the OCR comes in. Okay, because what the optical character recognition module does is it basically, like your license plate number on the M25 cameras, it's actually reading the number itself. Okay, so it says that should be serial number 256785, and it's actually 25678 because you put touch ink on the 5. Okay, so that's the kind of thing that the OCR will pick up. And again, people like BST and the ABTs, they've all got these modules that you can add into a basic system. The other thing that it's not very good at doing, it's not very good at checking color. Okay, so it's not really saying that camera isn't saying that's the orange that I'm checking for. What it's really doing is it's just checking for obvious printing mistakes. So the kind of printing mistakes are print defects, pinholing. Okay, pinholing is where for some reason there's something on the plate stopping the ink getting onto the material, leaving little holes in the print. Hickeys. A hickey is where something lands on a plate during the print run, a fly or a bit of hair. Or unpleasant things can fall down from the roof or whatever and they land on a plate, and then they get obviously transferred onto the web. They get transferred onto the web, or they stick on the plate like you see with flies. I mean, especially if you go anyway. I was at a plant in Indonesia, and I'm like, why have you got that window open? There's always kind of anyway. So what happens is people then get sticks. They call them hickey pickers, and they get sticks, and as the press is running, they're trying to kind of get these flies and things off the these things running like that. So your hands in there, and that shouldn't ever happen now with a modern press because you should have machine guards. But actually, once the installer has gone home, and just take the guards off, because the guys don't want to stop the press. So you see all this sort of dangerous stuff going on. So that's a hickey, and again, in a modern controlled plant, especially a food-grade plant, that should never happen. You should have electrocutors everywhere. You should have everyone's wearing hats, right? So your earrings not to fall on the web, and blah blah blah. But that stuff can happen. So that's what one of the kind of key things that the camera's really looking for. One problem that you can get with inkjet is that if you have like an inkjet press, so on a 13-inch web, you've probably got, I don't know, I mean, there are thousands of little nozzles, tens of thousands of nozzles. And if just one of those nozzles gets blocked for any reason, you're going to get like a white line starts to appear on the label. So that's another thing that the camera can look out for. It's also looking out for misregistration, as we said before. It's just checking those registration marks, making sure that everything, the distance between the plates is fine, everything's landing where it should land. And then dot gain. And dot gain is where there's too much. Remember when we talked about flexography, and what we said was that because it's like a soft dot, like that with the ink on top of it. Remember that plate, that soft plate? If you press too hard on it, okay, so if you're pressing too hard against the material, which is going through there, then you're going to get squashing. If you get squashing, you get too much ink, and then all the colour goes completely wrong. Instead of 30% cyan, you suddenly got 40% cyan, so the whole colour's gone wrong. So the other thing the camera's checking for is dot gain. And then, so it's, as a colour, although it can't tell what the colour is, it knows what the dot size should be. And if you start to see those dots getting bigger and spreading, then again you get an alarm. So the camera's checking for all these things, but ultimately it's the operator who has to be able to interpret what they're seeing. The camera's just going to show that stuff happening. But with the new AI cameras, the camera can now actually sort of start to make judgments itself. So as soon as it starts to see something start to go wrong, then there's various ways it can alert the press operator, and that might be like a traffic light system. So many times you'll see a press, like a label press, and you'll see a traffic light, green, orange, and red. Everything's fine. If it's green, start to see something start to go wrong, it goes to orange or yellow, and it's basically saying to the operator, you need to have a look at this, you know. And what it'll then do, it'll then say, I think the camera's saying, I think this is going wrong. You know, you need to check it before it goes into the red. If it's something like a hickey, something that lands on a plate and starts going round, then it'll just go to red instantly. In some cases, it'll stop the press. If it's a critical job, it'll actually stop the press. But the press operator's job then really is to decide, is that serious enough for me to stop the press? Because there's not a lot you can really do. You know, if something's gone badly wrong, you just have to stop the job, work out what's gone wrong, probably make the plates again, run the whole thing again. So for the press operator, it's a real kind of critical decision, and that's really where AI is always going to need a human. You know, the AI can say this is about to go wrong, but it can't say, and this means you've got to stop the job. You know, that's kind of still where there's a bit of human control is needed. Right, okay, so on the rewinder, you also have the same camera. So again, you've got your inspection rewinder, sometimes called a sitter inspection rewinder, because what the rewinder does, it takes your printed roll from the press. So it's been die cut, labels have been die cut out of that. It puts it on the rewinder, then it unwinds it again on the rewinder, and comes across an inspection table, and you'll see the rewinder operator looking at this inspection table. And if they see a bad label comes along, or the camera tells it's a bad label, then they slow it down, have a look, stop it, get a pair of scissors, cut it out. It's all pretty crude stuff. Then they splice the web back together with a bit of tape, and off it goes again. So the idea is that what the rewinder operator is doing is they're actually taking off all the bad labels before they get to the customer. Obviously, what that means is you probably have to overprint, because you've got no real idea how many bad labels are going to come off that press. So most printers overprint by about 10 to 15%. They print about 10 to 15% more labels than they actually need, because they can't really be sure. You know, once they've taken off the bad ones, they obviously need to have enough, because if you haven't got enough, you've got to reprint the job and blah, 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 blah. So one of the biggest sources of waste in the label plant is just that, overprinting. And then because if it's all good, then you just chuck it away. You just throw that 10% away. It just goes in the bin. So, right. So that's a rewinder, and the other thing that the rewinder operator is looking for is if the matrix has been properly stripped. So if you think about when you die cut, then when you're die cutting, you have like your cookie cutter. It's going over the web like that. The shape of the label you want to cut out. It's cutting out that label shape, and then it's pulling away the waste, the matrix waste, and it's widening that away. But if that breaks for any reason, you've still got that matrix is still on there, then that label won't come off when you try and put it onto a container. So it's another thing that the rewinder operator is looking out for these things. Okay, so one thing that you'll see this at the automation arena. It's really kind of worth looking at the AVT camera and what that's doing on the automation arena. One thing that camera is doing, because of this whole issue about printing too much because you can't control it. But on a digital press, because you don't have a lot of these problems, you don't have problems with print pressure, you don't have problems with registration, because it's just being printed directly onto the sheet. There's no plate involved, there's no squashing. So digital presses are much more accurate and have far fewer problems. So what the camera does on a digital press, like a Zycon or a Mark Andy or whatever, hybrid, is it just counts the good labels. And when you print enough, it stops the press. Okay? Because why would you carry on the digital press? Print enough good labels, stop. So what AVT is now doing, they have trying to get a similar kind of system now on a conventional press, saying as soon as you get to, our camera is looking at this label web. Okay, if you printed enough good stuff, I'll just stop the press. You know, rather than carrying on printing 10% extra, I'll just stop the press when you print enough good labels. So what the AVT camera system can now do is you have a traffic light. So it's green, it's amber, potential problem, it's red, which is press stop. What it's doing is, all the time it's green, it's counting the labels. Okay, when it goes orange, it says to the operator, do we have a problem here? The operator says, okay, yes, but it's acceptable. So it goes fine, it carries on counting good labels. Gets enough good labels, it just stops the press. So it's trying to cut down on the amount of overprinted labels. Okay, so they're the basics really of inspection. Some of the new developments. So the first one really is called the roll report. Useless. And so this is really pioneered by AVT. Although now BST's got it now, Ultramat's got it, everyone's got it now, Earhart and Lima, they've all got it. But what it basically is it's a way of taking the camera off the rewinder and doing all your inspection on the press. And then controlling the rewinder from the press camera. So effectively what you're doing is you're running a roll of material on the press, you're inspecting it with the camera, and then whenever it goes red, rather than stop the press, it just marks it. It says, right, that's a defect. And it then puts that onto it's like they call it a roll map, and it appears on a PC. So it's PC now. The quality control operator can watch this anywhere. It could be anywhere. It could be at home on a tablet, or it can be in the QC office. What it's doing is he or she is just watching these defects go through. They can blow them up. Okay, so they can zoom into a particular defect. So, for example, if you had a defect, some defects are going to be terminal for a job, and some aren't. That's a matter of human judgment. So for example, if you had this image here, and let's say you had a slight bit of pinholing up here, but actually you've got an area there where you probably not going to notice it because, you know, it's a kind of dappled type of area. So getting the little pinholes there might not be an issue to stop the job. If you start to get pinholes there, or in sunglasses, then that's a massive problem because you're going to see it instantly. You can see there's a hole in the image there. So there's the kind of human judgments. That's the kind of judgments that the QC inspector looking at their screen, and there may be 5 machines going, and they're just looking at reports of 5 machines saying pass, go, pass, stop, pass, stop. So at the end of the process, the QC guy on the PC or a tablet has identified all the bad labels, the ones that are passes, and the ones that are definitely fails. Then that information, this is really where AVT worked with CERM and initially with Prati, although all the Rewinder guys now can now do it. It then goes directly onto that role, that digital file now controls the Rewinder. Okay, so what you've done is every time that you've got a defective label has been marked, the LinkJet thing just barcodes it on the back of the web. So when it goes onto the Rewinder, it's all hands off, right? No one needs to touch it. When it gets to that part of the web, it reads the barcode, just stops it. So all the operator does is just literally, then they just get the scissors and splice it. Okay, so there's no camera now on the Rewinder. All the inspection is done on the press. That file then goes to the Rewinder, and that runs a Rewinder. So the Rewinder stops at exactly where the press has found a problem with that label, and the QC person says that's a bad label. So even now, the Rewinder operator's job is already being de-skilled to an extent, because all they're really doing now is they don't even have to stop it, it just stops in front of them. They cut it off it goes again, stops again, bad label, cut it off, splice it. So that really is now becoming a de-skilled job. And some people now on higher run jobs, people like GM and these guys are now looking at ways to automatically cut those labels out. So it's not a difficult thing, you're just going to need an automated pair of scissors really and a splicing unit. So the time will come pretty soon where you won't need anybody on the Rewinder. All the inspection will be done on the press. A lot of printers who still like to have that security blanket of putting it onto a Rewinder with a person and a camera. And if you've got really super high quality stuff like toiletries and cosmetics or pharma, you're probably going to have a kind of double inspection system. But for most labels, probably that operator will probably go in the next 2 or 3 years. The second big development is doing away with this golden image. So this idea that we were talking about, that what the camera does just before the job starts, and when you've made ready, you're just about to ramp it up to speed, it takes a photograph of the first label it sees and uses that as a reference. But as we've said before, the problem there is you can't do any variable data, because obviously it's just one, whatever the data code is on that one that you photograph, that's what it's going to look for, so it can't look at serial data, it can't look at color, and it can't look at whether that image is actually right or not, because it's just taking a photograph of the image. So ESCO, again, working with the beloved CERM, where will we be without CERM? But they really have kind of pioneered this stuff, the way that things tie together. So what CERM said was, okay, but all the information that you need for the camera is in a PDF, right? Because that's what the customer's passed. At the end of the day, that's a printout the customer gets of a PDF, okay? But the actual thing that they pass is a PDF. Just like here, when Ben's labels and labels about to go to press, and what Ben gives us is a PDF, and we proof the PDF, and that PDF we can print it out. But what goes to the printer is a PDF. So what Geert says is, well, if all the information that we need is in the PDF, and then why don't we just tell the camera to look at the PDF and forget about golden image stuff, and then, then you can have multiple PDFs. So every time that serial number changes, we just kind of flip another, and use that as a reference for the camera. So they went to ESCO, and ESCO said, well, that's a great idea, because in our system, we have the PDF. That's what we do, right? We're the pre-press guys. So then they go to AVT, CERM goes to AVT and says, could you do it? If we gave you a PDF of that image. So AVT then do a bit of research, and a couple of years ago, the first system started being used. And now, again, you'll see this happening on the automation arena with the AVT camera. So what you'll see, like last year, you'll see the pre-press guy or a lady, you'll see them basically bring out the PDF, send it to the customer for approval all over the internet. The customer will approve it probably on an iPad. Very rarely these days that anybody sends out hard copies to anybody. So the customer will approve it on the screen or on an iPad, goes back to pre-press. The pre-press operator will then say, sat there on their Mac or their PC, okay, that's the image that the camera is going to control. So I'm not too worried about all this, but I am worried about skin tones. So what I'm going to do is I'm going to make sure the camera hovers over that part of the image. So when the camera goes onto the press, it automatically moves to that part of the image. Okay, so the camera, as we said earlier, the camera's on like a movable frame like that. So it moves and sits over that part of the image. But that's the part of the image that the pre-press guys, that the brand's concerned about. That's got to be right. Even if these parts aren't, you know, slight problems with issues with them, you can't really see. But the brand color, certainly skin tones, any key parts of that image. So whereas before, it would have been the press operator doing that, you know, manually moving the camera over, making sure that almost by hand control. But now it's the PDF, so the PDF comes up and the pre-press operator just puts marks where they want the camera to patrol, if you like. Patrol this area, patrol that area, patrol this area. Then the camera then automatically moves around to those images. So what this means now is that we can now control variable information, we can now control all the text because the camera knows exactly what the text is it has to be looking for. Okay, so that's the PDF. Color. So the other kind of area that as we said before, the early systems, I'm just taking a photograph of that. They didn't really know what that color was, you know, so they couldn't really check if that's the right color. All they knew is if there were problems, if there was a fly landing on it, or if there's if there's too much dot gain, the dot's getting too big, but it couldn't say that is orange Pantone 56550. So again, our friends at AVT, working with Bobst, you know, these names keep coming up. I mean, Bobst, you know, Federico, Bobst, AVT, CERN. These companies have really been driving this whole thing 4 or 5 years, and Federico had provided the money for it, because what he said is, you know, you're not doing this in a vacuum, I'll put it on my press. You know, I'll sell it to customers, you know, so now everyone's playing catch up, you know, everyone's now getting these systems on their press, but really, you know, the person who drove it all was Federico. Even back in the Guy Doué days, he was really driving this stuff. You always ask the question, why? Why do I have to have someone looking at that? Why is he wasting his time at the end of that machine looking at that when it could be automated? You know, why can't we look at the color? You know, why can't we measure the color? And he was saying, well, you can't because we're just taking an image. So, but why? Well, because we haven't got a spectrophotometer. Well, then put a spectrophotometer in the camera. Oh, okay. Right. So what AVT does into their camera, their inspection camera, they build a thing called a spectrophotometer, and we might have touched on this briefly earlier when we did the color. So what a spectrophotometer does is it basically bounces light onto an image, and what comes back, reflected back, it captures as the color reference. So what it knows is that orange there, if you take like a Pantone book, is that exactly that orange. You can give it a number and a name. So what a spectrophotometer can do, it should say that color should be exactly this orange. And that color should be exactly that orange. So what a spectrophotometer is doing is it's measuring the color that's bouncing back off that image. And it's already gone to the proof and done exactly the same thing. It's bounced the color off the proof. And it said, right, that is exactly that shade of orange that we're looking for. And if you may remember, cast your mind back to a thing called delta E. And what delta E is it's a measurement of color when we humans start to see a variation in color. So if two of us are looking at that orange, around about delta 3 is where the human eye starts to perceive a color difference. So you can have slight variations of color up to delta 1, delta 2. Get to about 3, you start to notice it. By the time it gets to 5, you can definitely notice that there are two different shades of orange. So what the AVT camera is doing, and now BST and now Ultramat and all the other guys, they've all got the same systems now. It's measuring that color and it's saying, if two humans were looking at that color, would they be able to see a difference? And as soon as that delta gets to beyond 3, the red light goes on. So we can now see serial numbers. We can now measure the colour, and we can, so a lot of the things which are, a lot of the weaknesses with the early systems that just took a golden image have now kind of been addressed. So I'm using the original digital file. I'm also controlling now for variable text and now controlling for colour. Okay, so where do we go next? And where we go next is these systems now starting to control the machine itself, the press itself. So this will be the kind of final stage where the operator finally starts to get sent away from the machine. You just asked that question earlier, Rich, about what stage in automation do we start to lose jobs. And if you look at the Bob's press, but look at the MPS press in the automation zone, it now has all these bells and whistles. It has a full AVT system. It has the pressure measurement, right? Pressure measurement. This is the last thing to talk about, really, before UV. So, automated pressure measurement. So, on a flexo press, as we said, most of our printing is done still with a flexo press. We said that the real problem is that you've got a soft plate with the image standing up off it. You're rolling that onto the paper or the film, and if you have too much pressure there, it's going to squash. Okay, so you've got too much black now. You've got too much cyan. You've got too much, so the whole thing's finished. You know. So you have what you just call a kind of kiss touch. Just you touch it just enough. It just transfers the image. And in the old days, which for most people is still the case, when you're making ready the press, so the press is going really slowly, and what the operator is doing, they're going from print unit to print unit, and they're eyeballing it, and they're just got a little pressure gauge, and they're just doing this and doing this and doing this, and at the end of the press, look at the camera, too much, come back and just back off the pressure a little bit. They're doing that to every single print unit. So it's going to, one of the reasons that those flexo presses took so long to make ready was that all this is done by eyeballing. And that's why you need the guy with 25 years experience to go up and down that machine, because as the machine's running, it's a mechanical device, right? And there's a lot of pressure in that machine, a lot of tension on the web. So these things can change. So the whole time is spent going up and down the machine doing this, looking at the pressure, changing it, backing it off, looking at the camera, back off again. So Federico, again, why can't we have something on the machine that looks at the pressure, and when the pressure gets too much, it just backs off the pressure automatically. So what Federico did, and again goes right back to the days pre-Bob's days. So that's your plate cylinder. So again, the plate's standing up like that, and the ink is sitting on top of the dots. And you're running that against your material. You've got your impression cylinder there, just holding it in place. And you've got your Analox roll there, which is putting ink onto the plate. Okay, so that's what you want to control. You want to control the pressure between that and that. So quite ingeniously, Federico and AVT came up with an idea, and that's if you just printed like a patch of pixels like that, and you know that at the exact right printing pressure, that's exactly how big it has to be. Okay, now, if you get too much pressure, what's going to happen? That's going to squash, right? So that's going to start to look like this. So as soon as the camera sees that happening, it says, right, it's too much pressure. So it sends a message to the servo motor controlling that and just tells it to back off. It just backs it off. So you have a little motor here on this cylinder which moves it this way and that way. Okay, so if there's too much pressure squashing, that image is going to get bigger. So you just back off the pressure until it comes back to the right size again. If you don't have enough pressure, and obviously that image is going to be smaller. So it just does reversing, just tells that servo to increase the pressure. It just moves it up against, increase the pressure until you get the right amount of squash, right amount of dot gain. They're really, really simple. Federico was doing that on Bob's presses probably about 2 years ago, but now it's non-proprietary. AVT can now sell it anywhere. So you'll see a Mark Andy press has this now, MPS at the automation zone. So what it means is now is that that operator does not anymore have to go up and down the machine. So now you can see a make ready of a flexo press. It's fully automatic, hands off. Okay, so things starts to print, go slowly. The camera is looking for, the traditional camera is looking for any print problems, hickeys or splashing of the ink or whatever. The other camera is looking at the color, and another camera is looking at the registration marks, and another camera is looking at the printing pressure. And it's all been and it's being fed back through the press to all the motors that control all the cylinders on the press. So the press is adjusting itself, and it does that throughout the print run. So that person doesn't have to do it anymore. And then Richard's question was, well, then what happens to that person? Do you just sack them? Well, no, probably what you can do with that person, you'll make them the QC person. You'll make the QC person who sits there looking at those roll reports, defect reports coming off the press, and deciding if that is a critical error or not. So what you're doing is you're redeploying those skilled people, but into a really useful role, basically kind of customer service QC type role. Okay, so that's really print inspection and where it's going. Where it's going eventually, as we said, is that you'll just have AI systems. So Brotec at the moment is doing a project with who did we see in who did we talk to in China? Yeah, he was working with Global Vision, was it? Global Grab? He was working with that. But he's, but their project is the Lusterlight people and the Lusterlight and Global Vision. So they're working on this system where they're uploading all this data from their cameras all over the world into big data systems. The big data system is saying, as it's looking at something, even before it's been printed, it's now saying, as the press is starting to make ready, so this is going to go wrong because you haven't made that plate properly. That plate's not properly. There's too much pressure here, too much pressure there. It's automatically adjusting it, and it's feeding that information back into big data, which then helps the next time that you install a press. All that information intelligence is available for next press. And Federico now at Label Expo, it's been brought down to an entry-level press now, which is his M1 press. And you'll see that at the show linked up to a big data database, which is basically giving constant advice to the press operator. But it can't do anything about it because that press is driven by gears and mechanics. It's not driven by separate motors. But kind of shows where the industry is going. So just finally then to talk about UV. So why is UV dose measurement important to quality control? UV dose measurement. Okay, so as you know, most of the printing that's done, and I kind of really try to stress this, virtually 90% plus of the printing that's done on labels is done with conventional equipment, okay, not with digital presses. And most of that is using UV. And even on the digital side, pretty much all of the production quality inkjet all uses UV. So UV is the big one. UV is important because, if you remember, kind of thinking back to what we said about UV, dries instantly. Okay, so any print speed, because it's a chemical process, not like evaporation. So as soon as that UV hits those little buzzy bees, right, and then that ink immediately becomes a solid film. And it means you can run a press at any speed. You don't have to worry about the ink not drying before the next ink comes down onto it, all this kind of stuff. You don't have to have big drying tunnels like you do with the water-based presses. So UV is a fantastic, efficient way of drying inks at a very fast speed. There are issues, as we know, with the migration problems and stuff, but I'm not talking about that so much here. But the key thing about UV is that you must have enough UV energy or power onto the web to get those buzzy bees, okay? Because there's the ink, it's the buzzy bees, which are the photo initiators. And they're kind of buzzing around with loads of energy. Then you've got your UV lamp is up here. And if I get a certain amount of power, UV power coming down, all those will be bonded to the web, and that will become like a solid film. But as I said, the problem is, if you don't have enough power, then some of those that will be so powerful, also so much energy, they can go right through material, right through a bottle. So they're really kind of nasty stuff. Once they're in the bottle, then they're in the food, in the drink. And that's where the problems start to come, because they're carcinogenic. So you need a way of making sure that UV is cured. So the problem that you have is if you speak to GW or any of these guys, and particularly GW, they already monitor every single lamp about big data. Every single lamp that they put in, they told us, every lamp they put in is hooked up to their big data database. So they can they can look at the press anywhere in the world, and they can see exactly how the lamp's behaving. And it's pretty shocking stuff, really. A lot of these lamps aren't being changed when they should be changed. The power output isn't as high as it should be because they haven't cleaned them. Basic stuff. They're not doing maintenance on them because nobody wants to stop the press to do maintenance. And just keep printing. The lamps get dirty. The power comes down. Or the press operator doesn't read the instructions on the ink, because the speed you run the web is important as well. If you run the web too fast, you're not going to get enough power coming to any one part of the web to cure those inks. So you've got to make sure the press is running at a relatively modest speed, and also that the power of that lamp is adequate, that it's clean. So up to now, you've been able to get little monitors that sit inside a lamp and basically say, this is the amount of power this lamp is giving out. The problem is, it's not telling you how much is actually hitting the web, not telling you whether that's dirty, the glass is dirty, or how well it's been maintained, or what it can really tell you is whether that lamp needs changing, okay? Because as soon as the power drops below a certain level, it'll tell you. So what GW are going to do, again, Federico has been pushing this, and you'll see this on his M6 press at Label Expo. So what GW done, they put the rather than having the sensor up in a lamp, they've moved it so it sits just above the web in front of the lamp. So now it's measuring pretty much. It's not actually on the surface, but it's about a couple of inches off the surface of the web. So what it's doing is it's measuring the amount of energy that hits that part of the web, and it can then say, ask Flint or Sun Chemical, how much power do I need at this web speed to cure this ink on this material? So they know exactly what that figure should be, so they just have a little monitor up there that says yes, no, has enough ink, enough power reach the web. What you can then do is you can then, again you'll see this on the M6 press, you can then have a report that goes out the end to the end user and to the QC person saying every meter of this web had exactly the right amount of energy into it. Okay, so that's just to wrap things up. You might have heard about offline testing. So what's offline testing? All this is happening on the press, okay, or on the rewinder. You'll also see when you go to a label plant, you'll see a little lab, a little laboratory, people with white coats. And what they're doing is they're running quality control tests on the finished label. So they'll be doing the same kind of thing. They'll be getting a spectrophotometer, measuring the colour. They'll be looking at the image, making sure there's no pinholing, just doing a kind of final check on random samples of the label. But then the other thing that they're doing is they're testing for whether the ink is going to rub off. Okay, and Finat has a whole book of tests, which basically show you how to use a rubber on a pencil, or various types of, or bits of tape. So you just put a bit of tape in there, you leave it on certain times, pull it off. If any of that ink has come off, then it's failed the test. Basic tests. But the last thing that you want, and particularly if it hasn't been cured properly, is to find out when it gets to the customer rather than in a lab. So the people who do those kind of QC things, people like RK Print, testing machines in the US, these sort of guys. So the people who do the handheld measurement systems like spectrophotometers, people like X-Rite, yeah, there's a whole bunch of others. But so, and that's it. So that is inspection.